Okay, we're at time, so we're going to get started. Hello and welcome to our session, Process and Render Petabytes of Data with Mapbox Maps. My name is Greg Banneker, your host. I am the Senior Product Marketing Manager at Maps at Mapbox, and I'm joined today by Osa Fursell, Senior Product Manager for Mobile Maps, Alistair Miller, the head of our imagery product, and Matthew Anthony, our senior product manager for studio and developer experience. Before we dive in, just some quick housekeeping notes. You should see your chat and Q&A icons in the menu at the bottom of your screen. Please use chat for any general comments. If you have specific questions, go ahead and put them in the Q&A box. So we want to start today's session with a story about how one of our customers, Ordnance Survey, uses the full Mapbox platform to increase user engagement and satisfaction. So let's hear from Nicole Frith, product manager at Ordnance Survey.
Hi, I'm Nicole Frith, a product manager for OS Maps at the Ordnance Survey. OS Maps is an outdoor leisure application which helps millions of people to get outside more often all over the world. It provides users with access to worldwide mapping, as well as routes and activities and inspiration for their walking, cycling, and other outdoor adventures. It's brought to you by Ordnance Survey, the national mapping agency for Great Britain. Using Mapbox and OS Maps, we've been able to expand our global offering quickly and easily and provide mapping and imagery to people all over the world. It enables us to quickly and easily create new and custom map styles and deliver these to around our 1.5 million users. Using tools such as Mapbox Studio, we can create powerful custom maps and bring together our world-class Ordnance Survey data with other geospatial information and update the maps and layers in OS Maps in near real time and push these changes to our users. So they'll always be equipped with the most up-to-date and accurate information to safely power their adventures. Mapbox's offline and 3D capabilities help our users to both feel more safe when they're planning and doing their adventures, and also to visualize their adventures in better ways than ever before. So thanks, Mapbox.
Ordnance Survey is just one example that illustrates how Mapbox Maps is a full platform offering of upload, design, and rendering solutions that really work together to take your large amounts of custom location data and turn it into beautiful interactive maps. And now we've been working this year to help make that process even better by improving the efficiency, performance, flexibility, and accuracy of the Maps platform. And one key method that we use to drive improvements to our product is actually talking to our customers and surveying our customers, like Ordnance Survey. So I'm going to pass it over to Osa Fursell now, our senior product manager for mobile maps, who is going to walk through how we actually had a recent power developer survey and how that influenced some key changes that we're releasing soon to the platform. So off to you.
Great. Thank you, Greg. I'm really excited to talk to you about some of the new features and improvements we are about to release in our SDKs. And as many of you know, especially if you've been developing with Mapbox for a longer time, V10 was a major update where we refactored a huge chunk of our SDKs to enable the future of map rendering. And our upcoming major mobile SDK release, V11, on the other hand, is the kind of natural evolution of the work we did in the V10 series with a relatively low migration effort. Same can be said for our web renderer GL JS's new major version V3, which follows the long-standing V2 series. And when we started planning V11 and V3, we spent quite a lot of time trying to understand what is it that our developers are struggling with, what are the use cases that they're trying to achieve with our SDKs, and what are the things that they really like and love about our SDKs, because obviously we do not want to touch these things. So instead of focusing on concrete features and capabilities, we really wanted to dig deeper into the developer experience as a whole. And this meant spending hours going through GitHub issues, browsing Discord conversation, talking directly to developers, and like Greg mentioned, sending out surveys. And it turns out that 40% of the mobile developers choose Mapbox because of the tools we provide and the frameworks we support. Oops, sorry about that. I'm gonna go back to the slide. Yeah, now we're on the correct slide. So most specifically, 3 technologies kept coming out in our conversations: Flutter, Swift UI, and Jetpack Compose. While development with all of these frameworks has been possible through various wrappers and community-driven projects, it was really clear to us that our developer community expected more streamlined and officially supported solutions. And through this exercise, we also wanted to get a better understanding of your priorities as developers and as businesses. And the biggest priority for most was the overall quality of the user experience and of the applications they deliver to their customers. And if you joined this session from the talk on the standard style and the 3D map design, I hope you'll agree that we've taken quite a few steps to make sure that you'll be able to provide the best possible UX for your customers going forward as well with Mapbox. But following the UX, key priorities for our devs were speed of development, application reliability, agility, and overall cost reductions. And these were really strongly represented. So the feedback was clear, and it also reinforced the gut feeling we had before we started this V11, V3 planning journey. So we heard you loud and clear, and that's why the major focus of the new releases is around developer experience, ergonomics, efficiency, and ease of use. And to improve the developer efficiency, we took strides to further support modern development frameworks. Like mentioned earlier, these have been available through various wrappers and projects before as well, but we've now taken steps to officially support and maintain them ourselves. First of all, Jetpack Compose, it's a declarative UI framework for Android development. Many developers feel that Jetpack Compose offers a more powerful, flexible, and efficient app development environment compared to the older XML layouts approach. So we've introduced support for it in V11. On iOS side, Swift UI is similarly a declarative UI framework that offers quicker and simpler UI development over the older UI toolkit. And again, this is supported and introduced in V11. And last of all, Flutter support. Earlier this year, we released a beta version of our Flutter plugin that enables cross-platform mobile development. We're now ready to move it towards general availability, targeting early 2024. And many of you have already tested these out in the beta phase and shared feedback, bug reports, feature requests, and whatnot via GitHub and Discord. So we really highly appreciate all the feedback that we've been getting this far, but we also hope that you will keep it coming as we continue to improve on these technologies in the next year. And like the title of this session, process and render petabytes of data with Mapbox Maps suggests, maps comprise of an immense amount of data. Then on top of the mind-boggling amount of information it takes to put together the base map itself, our customers, you, add your own data on top of it to build bespoke location experiences. So considering this, it's really obvious that debugging, optimizing, and profiling these applications can get really complex. So to further address the speed of development, the reliability, and performance, we are releasing several new developer tools that should make life easier for all of our developers. First, the tracing API. It offers a detailed overview of the operations performed by the Maps SDK, including information on style loading, tile parsing, and various rendering events. You can also easily integrate it with tools like Xcode instruments to ensure a streamlined workflow that also aligns with the rest of your development processes. The Map Recorder API, on the other hand, simplifies the debugging and profiling process of your maps and allows you to record and replay API calls made on the map instance. And finally, performance statistics will give you deeper insights into rendering performance metrics. So how do these new APIs concretely help you in your day-to-day work? So let's take a look at a specific use case example of the Map Recorder API. So a very common scenario is that a QA engineer or an end user spots a bug in the application, or you as a developer spot an issue in our renderer and report it to us via GitHub. Like in this very specific example, you can see the video. Someone spotted flickering restroom labels on the map and reported it to the team. And quite often, the reproduction of bugs is rather difficult and very time-consuming, as the issue might only reproduce in a very specific environment. For example, the latitude and longitude has to be exact. The style has to be a specific style. Maybe the pitch has to be at a certain level, and the zoom has to be also at a specific level, or a certain animation must run for it to reproduce. And as many of you know from experience, sometimes trying to reproduce and debug an issue takes way longer than actually fixing it. And this is kind of where the Map Recorder API comes in. It allows you to record the map session and automatically capture essential details like device style, type, styles, runtime changes, and camera movements. And the output of this recording will be a compressed JSON file that contains all of the session metadata that you're expecting and the sequence of the API calls, which makes reproducing bugs a lot faster and also aids with the debugging. Then another example of the concrete benefits these new tools provide come in the form of performance profiling. And a very common situation among our developers is that one might add a new layer to their map that contains huge amounts of information, like in the videos shown on the slide, where one of the maps has a map without any points of interest, and the second one has a map with all of the available points of interest with absolutely no filtering. Obviously, if you add huge amounts of data to your map, the end result might be that the rendering performance is impacted or the CPU or GPU consumption is increased. And in these situations, it can be really difficult to figure out what exactly was the tipping point for the performance and where the bottleneck lays. Okay, a little bit of a technical issue there, but with the tracing API itself, you can get to the bottom of this really easily. You can identify those bottlenecks. So with the tracing API, you can run your application and get detailed information on things like load times of a specific layer. And the tracing API is available for the core rendering engine itself, but it's also available for platform-level Maps SDK functionality that's responsible for things like gestures, animations, and view annotation. So you truly get access to everything that's happening within the SDKs. So besides helping with identifying bottlenecks and optimizing the app performance, the tracing API also can help you make intelligent data-driven decisions on the impact and cost of new features or design choices that you're making in products. So this makes it also a great tool, not just for the developer themselves, but also for product owners, designers, and managers. So all in all, a lot of cool stuff is brewing under the hood. And besides the topics I've covered today, we have a long list of improvements coming in V11 and V3. And to learn more, I really recommend that you check out the migration guides. But now I'll hand it over to Alistair Miller, and he'll be talking to you about what's new with our Raster pipeline.
Great. Thank you, Osa. Really appreciate that. Hello, everybody. As Osa said, I'm Alistair Miller. I'm the product manager for the Raster team at Mapbox. I manage our imagery and elevation data, as well as our new Raster processing capabilities. Today, I'm going to talk about some processing and imagery related updates that are dropping in the coming months. First, as Garrett Miller, who I'll note I'm not related to, mentioned in the keynote, we're thrilled to announce that we're expanding our support of processing custom raster data on the Mapbox platform. This will allow you to leverage Mapbox tiling service to create raster tile sets of your own data, along with the vector processing that's already in place. This opens up lots of opportunities for our weather, telecom, imagery, UAV, and agriculture customers, among others, who regularly work with raster source data. One second as we get these slides working. All right, there we go. Bear with me for a second, please, as we seem to be going the opposite direction. Okay, perfect. So we're leveraging our 10 plus years of experience processing large-scale imagery and elevation data sets and turning them into highly performant raster tiles that can be used through all the Mapbox APIs and SDKs you currently use to consume raster data. We're also applying our highly scalable processing infrastructure, letting customers automate processing for data sets like 5-minute precipitation forecasts and have that all run within minutes. So speaking of precipitation forecasts, one of the great benefits of working with raster tiles for something like weather is that the numerical values that are in the source data persist into the tiles. So weather data often comes with multiple variables and time bands packed into the source files, and processing them using MTS creates tile sets that let you easily switch between the variables, such as like temperature or pressure or humidity. You can have distinct color values applied to different data ranges. And it also allows for querying of the underlying values at runtime. To support the management and styling of raster tile sets coming from MTS, you'll have a variety of options of how and when you might choose to apply color values. If you're familiar with MTS, it uses recipes, or which are really instructions, to tell the system how to process the data. You may have different needs to process geotiffs versus GRIBs versus netCDFs, these different formats, and the recipes let the system know how to create a tile set. We'll be adding Studio support in 2024 to use for styling customization, but you can also assign color values in the JavaScript code and style on the client. As you see here, be able to identify a color range, specific colors for different values, or to choose what type of resampling method you want to apply to your raster data. We're also making improvements to our renderers to support particle animation as part of the upcoming GL JS and SDK releases. The time series data you see here on the left takes precipitation forecasts in this case and splits the time bands to allow for frame-by-frame navigation. Particle animation, which you see on the right, will let you create the sensation of motion by introducing data interpolation and smoothing, allowing you to create experiences like the smooth wind map that you see here and being able to animate across multiple different inputs in terms of intensity and direction for something like wind. So putting it all together, you can create experiences for your users that let them interact with raster tile sets in ways they couldn't do before. Working with raster tiles allows you to create much smoother visuals with greater color combinations and gradients. There's also the ability for client-side querying, so you can display the temperature or whatever other variables represented underneath the mouse, or configure it to display with a click. It also lets you select from predefined color palettes, change the range of values, or customize specific data value ranges on the fly, giving you an almost unlimited number of options to colorize and style your data. MTS for Raster is currently in a limited private beta and will be available to all of our customers in Q1 2024. We're really, really excited about this. So switching gears for a second, but still staying on the topic of raster data, we've heard from many of you and other customers about the impact of aging imagery on your operations. To that end, I'm very, very happy to announce we're adding a significant amount of new aerial imagery. We recently entered into a multi-year agreement with Vexcel Imaging to update and maintain aerial imagery over the United States, Canada, and Europe. We're really excited to work with Vexcel as they offer consistent data across those geographies, the high resolution that you all have come to expect, and best-in-class positional accuracy to ensure real-world locations are represented accurately on the map. In addition to the great imagery we're getting from Vexcel, we're also adding a substantial amount of open source imagery covering Europe, including our first ever aerial imagery over Poland. What you see in these maps on the screen represent the planned areas that will have sub 25 centimeter resolution imagery by Q1, covering a total of more than 2 million square kilometers. These updates will start landing this quarter and continue into early 2024, and will all be available in the Mapbox satellite style. So with that, I'd like to hand it back to Greg before we open things up to your questions. Thank you all for your time. I look forward to talking with you through the Q&A and the upcoming Maps Ask Me Anything session. Greg?
Thanks, Alistair. Yeah, so I just wanted to wrap this up very quickly by saying GL JS v3 and mobile SDKs v11, excuse me, and much of what we covered in this session are currently release candidates and will be generally available in late November. So I did list specifically what we covered in these sessions that is part of v11 and v3. So again, that should be generally available in late November. And I'm just going to take that opportunity to move right into Q&A because we did get some questions and I want to make sure we have time to answer. So also your presentation had some chatter, so I wanted to pass on to you. Are there any plans to support Compose multi-platform, aka Compose for iOS?
Yeah, that's an interesting question. We do not have an official roadmap for the Compose multi-platform, but we have looked into it. We have these internal hackathon events where our developers can look into new technologies and have started looking into it. But as of today, no roadmap, but would be really happy to hear about your use cases for that.
Okay, and I'm going to sort of stay in that universe. Are there plans to support React Native as well?
Yeah, React Native, the current approach with that is that there is a community project that's being maintained, and we are very supportive of that community project, and we are helping to get it migrated to v11. So as of today, we do not have plans to take it over ourselves and recommend customers to use the community provided approach. But of course, we're also open to hear your feedback on that and consider what we should do in the future.
And also, will 3D also be added in the Flutter package?
Yeah, so 3D is just part of our core render. So once we migrate the Flutter plugin to v11, it will also support the 3D styles and the 3D rendering. So yes.
Okay, thank you. Let me move to Alistair because we do have some questions for you as well. Are rasters first processed on the user's computer and then uploaded, or is all processing done server side?
Sure, that's a great question. So we're going to have out-of-the-box support for a number of raster formats. Some of the key ones, GeoTIFF, of course, NetCDF, GRIB, working through some others as well. So depending on the format, the native format that your data's in, it can just be loaded and processed and have that processing done on the server side. If there are, different formats or things that might be a little bit older, we're definitely happy to work with you to understand what type of support is needed. Obviously, there's a lot of work that we can do on the back end with GDAL to kind of work with some of those transformations. And as we grow our capabilities around processing raster data, we'll obviously be adding support, native support for other formats. But it's one of these, there's going to be some out-of-the-box support, but we fully encourage you to reach out and bring up the data that you have so we can understand how best to support it and really offload any kind of that work that needs to be done on your side and let us take that on for you.
Alistair, I wanted to keep going based off another question we got. So you did present definitely about raster data and the new capabilities that we rendering capabilities we have on the platform. But what are some other use cases you see beyond weather?
Sure. There's a lot of verticals that deal with a lot of raster data. Things that immediately come to mind, agriculture is a big one. We also have a number of customers that work with their own satellite or UAV data, which is almost always in raster format. That, there's ways to bring it to Mapbox today, but this is with the addition of, the expansion of MTS support really makes it very simple to have it create a tile set and then use all the Mapbox tools that you would to style it or to publish that data as part of your layers. We see work in the we work with a number of nonprofits and NGOs that have a lot of raster data. Think about in the forestry world, both on the commercial and nonprofit side, in oceanography and looking at some ocean data. And beyond what's, typically a lot of the times we think of, visible imagery because that's what gets a lot of the eyeballs. But there's things like elevation data sets where customers want to bring custom elevation to the Mapbox platform. And this is going to make it a whole lot easier to create that, to take that and create it into raster tile sets that are very performant and could be styled with different hill shade options and things like that, that really let you customize it and work with your data in a way that you want to and it's intended to.
Thanks, Alistair. And keeping with the raster theme, so how do we decide what areas of the world to update for our imagery, and give us just a little bit of that process?
Sure. There's a whole lot that goes into that. We, over the last couple of years, we did our last, actually a full global update at the end of 2020, early 2021. And since then, we've added about 20 million square kilometers of additional data that's been updated. We look at things like requests that are coming from across the board, across all of our customers. What are the hot spots and people where they're looking that also give an indication of where there's activity? We look at our internal anonymous telemetry data to understand where cities may be growing and where we might need to expand the areas where we have our highest resolution coverage to keep up with that expansion that's happening on the ground. We've created our own little internal indices that look at this combination of the requests that come in, our telemetry data, our traffic data. But then also we have to consider the availability of imagery. That's a big piece that I think with a lot of this audience, you're probably well clued in on. But if you look at the much broader Mapbox, community writ large, there's, I think, a number of misconceptions around how imagery is collected. There's not satellites that are constantly imaging the entire Earth every day. They're orbiting north to south as the Earth is spinning around in a circle. And so they get on average 15 passes in a given day. Now, a single company like Maxar, who supplies a lot of our satellite data, may have 4 or 5 operating satellites. There's others that the space industry, if you've been paying attention, has been expanding very rapidly. But there's still a number of gaps in terms of the availability of data. And then we have to also look at consistency. You don't want in your base map an image from the dead of winter next to something from the summertime. So we look at things like the availability based on the image dates. We look at how old the existing imagery is. It's going to be a lot more important to keep something like New York City up to date than it is, say, the middle of the desert in Nevada or northern Russia, for example, where there's not as much activity. So we do use human activity as a big guide for where to update, but we also look at things like the availability of imagery, where we're seeing other signals of growth. There's things like the crane index, where you can look to see how many cranes are in a given city to be a proxy for that development. And then we also, finally, customer input. While we don't have a mechanism in place today to update a specific area for customers, those requests that come in, whether it's via email, whether it's improve those map, those all get tracked and they feed into our internal index for how we want to update the map. And so please keep that coming. We're always welcome to the feedback, and it helps us refine and make sure that the imagery we're licensing is relevant for all of our customers.
Thanks, Alistair. And we did have one follow-up question while you were giving that answer. Will basemap imagery timestamps be provided?
That's, we get that question somewhat, some from time to time. And I think the challenge with that is not all of the data that we source comes with the same type of metadata or necessary, sometimes even collection data. So it's something where between the balance that we strike with open data and working with our vendors, that we're looking to see how we can unlock that in a way that keeps it consistent across all the imagery that we represent in the base map, because we have at least 24 different sources that are in the satellite base map today. It's probably north of 30 actually. And so trying to normalize across that can be a bit of a challenge, but we've definitely heard those requests, and it's something that we're working to see how we can make that something that's most effective for your use as a developer.
Okay, thank you. And thank you, team. We are at time. I do want to say that we are hosting a Maps Ask Me Anything session. So if you have additional questions that didn't get answered, as we did have a pretty active chat and Q&A, you can join that Maps Ask Me Anything session where a lot of people on this call will be there. And then we can possibly answer those questions there. But I want to say thank you to our presenters, to everyone on the call, and thank you to our customers for attending. And we'll see hopefully a lot of you on the Maps Ask Me Anything.